Here are solutions to quiz number 4 for ECE 320. The first problem is the MinMax circuit. Given the circuit, find the voltages, find the currents. So starting out, let's find the voltages. For these three diodes over here, only one of them is on. If the 3 volt is on, I lose 0.7 volts across the diode, and I get 2.3 volts. Well, that doesn't work, because if this is 2.3 volts, the top diode turns on. And you can't have both diodes turned on because the circuit's too dumb to get confused. So it's not both 7.3 and 2.3. So let's try the top diode. If the 8 volt diode is on, I get 8 minus 0.7, 7.3 volts, and that works. That tries to turn off this diode, that tries to force current backwards, and the third diode turns off. So this is 7.3 volts. Now let's go over here. If the 2 volt diode turns on, I lose 0.7 across the diode, and I get 1.3 volts. Again, that doesn't work because I have more than 0.7 volts across the diode, it turns on. And I can't have more than 2 diodes turned on. I can't have 2 diodes turned on when they're in parallel. So let's try the other extreme. If this is turned on, 6 minus 0.7 gives you 5.3, and that works. I'm trying to force current backwards through this diode, it turns off. Trying to force current backwards through this diode, it turns off. Now let's look at the middle ones. If the left diode is turned on, I get 7 plus 0.7, 8 volts, and 8 to 5.3 is too much. The right diode turns on, they can't both be on. So try the other one. If this diode turns on, I get 5 plus 0.7 volts, 6 volts, and I'm trying to force current backwards through this diode, it turns off. So those are the voltages. Now to find the current, 5.3 volts across 100 ohms is 53 milliamps. 7.3 volts over 100 ohms, 73 milliamps. 12 minus 6 over R, it's based on your birthday, 4.57 milliamps. So those are the currents that I know. Conservation of current says current in equals current out. This current has no place to go except right. It's got to go right, so that's I5, 4.57 milliamps. 53 milliamps is made up of this current plus the current from the 6 volt source. So this is the remainder, 53 minus 4.7, 48.4 milliamps. If you're curious, it wasn't asked for, but if you're curious, that's what that current is. And over here, 73 milliamps has to come from somewhere. That's this current. That is 73 milliamps. That's problem 1. Problem 2 is the same thing, just flip the diodes. This is a MinMax circuit. Again, on the left, one of these diodes is turned on, turned out to be the minimum diode. So I lose 0.7 volts across this diode, that'll be 3.7 volts. And again, trying to force current backwards, this turns off. Forcing current backwards, this turns off. Only one diode can be turned on. On the right, the smallest of them works, the 2.7 volts. Or this turns on, giving you 2.7 volts. In the middle, the larger the two wins. So the 3.7 minus 0.7 makes this 3 volts. I'm trying to force current backwards. This one turns off. That works. Only one diode is turned on. So first I find the voltages. Now find the currents. 3 volts across R gives you 2.28 milliamps. What is this? 12 minus 3.7 over 100, 83 milliamps. 12 minus 2.7 over 100, 93 milliamps. The 93's got no place to go, so that is this current. This is also 93 milliamps. The 83 milliamp splits. 2.28 goes right. The rest goes left. So this is 80.72 milliamps, if you care. And the 2.8 goes right, so that is I4. So there's the solution to problem number 2. Problem 3 is a clipper circuit. The Zener voltages are pretty easy. That's where they turn on. So the first Zener, here's your circuit. The first Zener is going to turn on at 7 volts. The second Zener turns on at 10 volts. Next comes the slope. The slope here is 7 over 3, which is 2.333. That's 1 plus the gain, 1 plus the ratio. So R0 is 1333 ohms. Got a mistake there. This slope is, it goes up by 3 and 4. This slope is 3/4. This slope is 2 over 5. I can find R1. For this circuit, it's going to be by voltage division, R1 over R1 plus R3. That percentage of your gain, which was 2.333. That should be 3/4. Solving for R1 when R3 is 1314, depends on your birth date, gives you 622 ohms. So this is 622. Then the last slope is 2/5. That gives you these two in parallel. R1 in parallel with R2. Over the total, R1 parallel with R2 plus R3. That times the gain of the op amp, 2.33, is 0.4. Solve for R12, and they'll give you R1 in parallel with R2. Take out R1, I can get R2, and that gives you 482 ohms. And that's problem number 3. Problem 4 is kind of a gimme. To clip at plus 3 and minus 6, I make this a 3-volt Zener, make that a 6-volt Zener, and they'll be off by 0.7 because this will actually have a voltage drop of 3 volts plus 0.7. Zener diodes are diodes. They've got about a 0.7 volt drop when they turn on, used normally. The Zener voltage when used backwards. So I would adjust each of these by 0.7, make that a 5.3 volt Zener, 2.3 volt Zener, and it should clip at plus 3 and minus 6. Problem 5 is given this circuit, draw the load line. Well, the x-axis, the intercept is 11 volts, right here. The y-axis is 11 over 40, 275 milliamps. Then at Vn is 4 volts, I get 4 minus 0.7 over R. IB is 2.51 milliamps, between 2 and 3, right about here, 2.51. I can calculate beta. So 5 gives you 250, 4 gives you 200. Beta is 50. That times 50 gives you IC, 125 milliamps. And then the voltage you can calculate, 11 minus I times R, 5.98 volts are right here. If you drew it graphically, it'll be right around here, right around 6 volts. The second one is if the N is 10 volts, I get 10 minus 0.7 over R, 7 milliamps. 7 milliamps is way up here. I'm trying to go in the left half in quadrant 4. That's not possible because if the voltage is negative, I'm producing energy. A transistor can't produce energy. So I can never go past 0. That's physically impossible. I also can't quite get to 0. Instead, I saturate at about 0.2 volts. If VCE is 0.2 volts, the current is 11 minus 0.2 over R, 270 milliamps. So that's what you should get for number 4. Again, your answers depend upon R, but same idea. And the last one. If I know these voltages, find the currents, find beta. So the current through R is the voltage across it, 5 minus 0.82 over R, 3.19 milliamps. 10 minus 5.69 over 20, 215 milliamps. And the ratio is your current gain. That's HFE. If you use DigiKey, beta, for some other textbooks, it's the gain. For me, the gain is 67. And the operating mode, I know I'm active on the load line. If I'm right here at 0.2 volts, that's saturated. If I'm way over here, if the current is 0, I'm off. Anything in the middle is active. And since the voltage is bigger than 0.2, right there, that's more than 0.2 volts, that tells me right away I'm active. So that's quiz number 4 for ECE 320.